Last week we talked about all the stuff that was on the quiz. This week we're going to do the last bit of that chapter 5, which is talking about gases. And then on Thursday we'll get into solutions. We may get into it a little bit today, but Thursday for sure we'll get into solutions. So let's talk about gases. Gases are a little bit different from liquids and solids because of their behavior, which we talked about before, that they always fill whatever container they're in. So there's essentially no attractive forces between molecules in a gas. And so whatever container they're in, they're going to spread out to fill that container. So this 100 milliliter beaker always has 100 milliliters of air, no matter how much actual air molecules is in there. Even if there's just a few molecules in there, it's going to spread to fill the container, and we still would consider that to have a volume of 100 milliliters. So that has some special considerations, because that means that volume is not a great way to measure how much gas you have. We care about like the number of moles, the actual amount of gas. We can't really measure it by putting it in a container and then expelling it from that container, because that container could hold any number of molecules or moles of gas. So that doesn't quite work on its own. Mass would potentially work because gases do have mass just like everything else, but they're really hard to measure because if the gas happens to be lighter, less dense, or the same density of air, then you can't weigh it because it would go up instead of down. It's not subject to the same forces. And then also that's affected by temperature, because temperature is going to change the density of most gases. So weighing it isn't really reliable either. So this introduces some problems when we deal with gases. And so we use another way of measuring gases called pressure. Does anybody know what pressure is? Have you heard of pressure before? Okay. Yeah, like how, so how would you explain that? What do you think is causing that? So it's a force, it has something to do with a force. Yeah, and it's not exactly a force, but it's a force that's pushing on something.
Like a force which is competing something.
Yeah, it's well, I'll give you like the physicsy definition of it, and then we'll talk about what that means for gases. So pressure is a force applied over a specific area. So like the most common one that we see every day that we actually don't use much in chemistry, but we use a lot in our own lives, is pounds per square inch, or PSI. If we actually look at what that unit is saying, pounds per square inch, that's saying pounds per inches squared, per square inch. So a square inch is an area about that big, right? Like a square that's an inch on each side. And if you took 1 pound of pressure and put it on a stick or something that was exactly that big, and you were applying it to that area, that would be that pressure. That would be 1 psi. So it's not just the force of the weight, but the force applied over the area. So here's an example of how it's different from force. We all exert a force on the ground, right? That's our weight. That's what we call our weight. It's how much mass we are combined with the amount of gravity that we experience, and we exert this force on the ground. So that's a force, not a pressure, but a force. If you are the same person and you are not changing mass, does the force that you exert on the ground change? No, doesn't. Right? You would have to change your size to change the force that's on the ground. All right. So now think about this. You're standing on some grass, and you're wearing regular shoes. Not a very exciting scenario. Standing on grass wearing regular shoes. All right, so let's compare that to you're standing on the grass and you're wearing high-heeled shoes with very skinny heels. What happens? You sink in. Yeah, I know, it happens to me all the time. So you sink into the grass. So why is that? Your force hasn't changed. What's changed?
Area.
The pressure is different because the area has changed. So instead of your force distributed over your regular shoes, your force is now distributed over a much smaller area. And so if it's force divided by area and you decrease the area, you're increasing the pressure, and that's why you sink in. So the pressure is not just the force, it's the force applied to the area. All right, so another example, mentioned tires. We think about the pressure, the air pressure in the tires, right? So think about a car tire versus a bike tire. What's like a normal car tire pressure?
30.
Yeah, like in the 30s. If you don't know that, you should check your car's tire pressure because it's important for safety. Anyway, yeah, so your car's tire should be about 30 to 36 or so PSI. You can, if you open the door on either the driver's or the passenger side, there should be a sticker that tells you what your tire pressure should be. Everybody go check it today, so you're not driving around on deflated tires. So anyway, yeah. Anybody know what a normal bike tire pressure is for like a regular sort of bike? It's about 80-ish, 80 to 100 usually. Unless you're talking about like mountain bikes with big fat tires, but like regular street bikes are usually in the 80 to 100 PSI range. So much higher pressure inside a bike tire. Does that mean there's more air inside a bike tire? No, there's way more air inside the car tire, which partially is because of just it's bigger, but also because there's a greater area that it has to push against because the car tire is so much bigger. So part of it is just the volume, but part of it is also the amount that it's pushing against. So you can pump up a bike tire to 80 to 100 PSI with a few pumps of a hand pump, but you can't get a car up to 30 some PSI without pretty much a compressor to do it, just because you can't move that much air. So the pressure is the force and the area. With gases, we'd say that the pressure comes from the gas molecules colliding with the sides of the container. So pressure in gases so pressure ends up being a good measure of how much gas you have, because now we have a solution to that problem. If we've got this 100 milliliter beaker and we want to know how much gas is in there, if we know the pressure, that'll give us a sense of how much gas is in there, because the more gas that's in there, the higher the pressure will be. So right now, what type of pressure determines how much gas is in there? Does anyone know what the pressure of gas in here is right now? What is it caused by? What is pushing down on it? Pushing down and out on things? The what? Yeah, it's the gravity of the atmosphere. So it's the atmospheric pressure being pulled down to Earth by gravity. And so we will often measure our pressure in relation to what we call atmospheric pressure. So some units of pressure that we'll use, of the units that we'll use, the main one is called the atmosphere, or ATM. 1 atmosphere is the amount of pressure the Earth's atmosphere exerts on the ground at sea level. That's 1 atmosphere. And we're approximately at sea level here, so that's about right. As you go up higher and higher, like in the mountains, the atmospheric pressure goes down because there's not as much atmosphere up there anymore, so there's not as much pushing down on you. But down here, there is 1 atmosphere of pressure pushing down on all of us. So that's a handy unit, especially when because we all have like a reference for what that is. So anything that's like more than 1 atmosphere is going to feel like more pressure than what we're sort of normally at. Anything less than 1 atmosphere is going to be less. Okay, another unit is millimeters of mercury, which is sometimes called torr. This is a weird unit because it looks like a length, because it's millimeters. But it's not a length, it's a pressure. And the reason it's a pressure is something called a barometer. Let me grab you a picture of that. So if you take a look at this diagram, you've got a bowl filled with mercury. Don't do this, by the way, because mercury is super poisonous. But back in the old days, they did this because they didn't know. Then they all died. So anyway, the air pressure pushes down on the mercury. If you invert a tube inside that mercury and you evacuate it, so there's no air inside the tube, the air pressure from the outside will push the mercury up the tube. And the distance that it pushes it up can be measured. And so that's where this millimeters of mercury thing comes from. At atmospheric pressure at sea level, the atmosphere will push the mercury 760 millimeters up that tube. So atmospheric pressure, 1 atmosphere, is the same as 760 millimeters of mercury, or 760 torr. It was recognized that millimeters of mercury unit is kind of a confusing, weird way of measuring things. So now it's more common to use torr, which actually has the same value, but is measured in a little bit different way. Yeah?
They use mercury to measure temperature.
Yeah, you can find mercury in thermometers also.
Okay.
If you see mercury thermometers, be careful with them because, again, poison. Some like older doctor's offices and things still use mercury thermometers because they are very precise and reliable. But if they break, then you're exposed to mercury, so you got to be careful with that. Yeah. The other thing to note, I don't know if you've messed with mercury at all, but one of the reasons mercury is so dangerous, obviously you can avoid it. You can like not eat it. If it's, if the thermometer breaks, you're not going to grab the mercury and eat it. But even if you're touching it with gloves and stuff, mercury has a high vapor pressure, which means that it forms a vapor. Even though it's this kind of silvery liquid, it's always forming a vapor also. So even though you can try to avoid the mercury, if it's around, you could be inhaling it. And that's why it can be dangerous even to touch it with gloves or something like that. Because if it's around and you don't have a fume hood or anything, you're still being exposed to mercury vapors. If it's enclosed in a glass container, then it's fine as long as that container doesn't break. Okay, so those are the main units that we'll use when we talk about gases. And in our lives, we'll use PSI a lot because that comes up with like your car tire pressure and that kind of thing. There's a couple other units of measuring pressure that I guess we can write down. The Pascal is one, that's the kind of the metric unit of pressure. which is about 101,000 to an atmosphere. So that's used for measuring really low pressures. Usually it's a very small unit, or very high pressures in the kilopascals. There's bar is another one that you might see sometimes, which is similar to an atmosphere. One that we see in medicine is inches of mercury. I don't actually know what that conversion is. We can look it up. It's the same idea as millimeters of mercury, but in inches. And this one is used for barometric pressure in this country. So when you're like looking at the pressure on the atmospheric pressure on the weather channel and it's saying the pressure is going down or up, that's usually in inches of mercury. And I think inches of mercury is also used for blood pressure. When you're looking at the two numbers of the blood pressure, I believe that is in inches of mercury also. But we won't use those too much in here. Okay, so with pressure then, whoops, let me save these notes here. Once we have pressure, then we can actually deal with gases and measure gases, and we can talk about how much gas there is in a given container. So with that, let's grab some goggles, and I have a couple demonstrations in the lab that will show us some of the relationships between these different properties of gases. I think it makes more sense to look at them first and then talk about them later. So let's go look at them and then talk about what they are.
We'll find out. That's from the other class. They really get sanitized that
I
good.
feel like he's so forgetful. He probably doesn't show up.
I know. Like every time I take it back. Yeah.
Unless that doesn't get the makeup off.
I don't think it gets the makeup off at all. You have to wait.
I know. I wish we just had like the ones that are sunglasses.
I'm so sorry.